Hello everyone, I am Arnav Vijay. I am from West Bengal. I have completed my BSc from Midnapur College Autonomous. I have been selected in various institute. Today I am going to share my interview experience at ICS Kolkata. For ICS Kolkata, I have gone through a written exam first. Then I have been selected for interview. Then the interview happened at least a 10-day later from the written exam. There were four professors in the panel. They first asked me about my favorite topic. I told that quantum mechanics, thermodynamics, and math physics. Then the first professor asked me some questions. So let's start the interview. The first professor asked me a question from thermodynamics. Draw the TS diagram of Carnot cycle and derive the efficiency of the Carnot cycle from it. So for this, we know this is the TS diagram of a Carnot cycle. That is where T1 is the temperature of source, T2 is the temperature of sink, where path 2 to 3 and 4 to 1 is for isothermal process, and 1 to 2 and 3 to 4 are for adiabatic process. And where Q1 heat is absorbed and Q2 heat is ejected in the reservoir. We know that efficiency eta equals to 1 output by 8 input. So again we also know that W equals to Q1 minus Q2. At first, entropy gain for isothermal process is Q1 by T1, and entropy loss for isothermal process is equals to Q2 by T2. And from the reversible process, we know that Q1 by T1 equals to Q2 by T2. That is Q1 by T1 plus Q2 by T2 equals to 0. Entropy change in adiabatic process is 0. Actually, dq equals to 0 for adiabatic process. Along the path 2 to 3, the entropy change S2 minus S1 is equals to Q1 by T1. Then from this we can get Q1, and similarly from the 4 to 1 path we can derive the entropy change S1 minus S2 equals to Q2 by T2. From this Q2 equals to T2 into S1 minus S2. And from substituting these values in this equation, W equals to Q1 minus Q2, we get the result S2 minus S1 into Q1 minus T2. Then just putting these values in this equation, T equals to Q1 W by Q1, we get the result 1 minus T2 by T1, where T2 is the temperature of sink and T1 is the temperature of source. Then the one professor asked me that for which system the thermodynamics is applied and why. Then I so that for normally macroscopic system thermodynamics is we applied. Then why actually in thermodynamics we deal with various parameters like pressure, temperature, and volume and entropy. Interact how they interact. Actually, we measure this parameter actually change when we consider the microscopic system. We have to we consider individual atoms where there is large number of atoms. But for macroscopic system, we consider the average or average behavior of the bulk number of molecules. So that's why we only use macroscopic system, not microscopic system. Then the one professor asked me a question from quantum mechanics. Actually, they first give me a wave function psi equals to x into x minus 2 for a infinite 1D box, and just giving the wave function, they told me to tell what is the length of the box. Just saying it, I just told that actually for the boundary condition, boundary at boundary, the wave function of 1D box is 0, and for that is psi equals to 0, and that is x equals to 0 and x equals to 2 are the 2 points where the boundary is for a quantity box, and from there the length of the box is 2. Then one professor asked me to derive the probability at ground state for this wave function. So we have to first normalize this wave function. So for this I have gone through a just simple normalization process. That is square where space is constant, normalization constant. 0 to x square into x minus 2 whole square into x equals to 1. Just solving the integration, I have got the result a equals to root 15 by 6. Then it is the well-known result for a ground state wave function, that is psi 1 equals to root 2 by L sin n pi x by L, where for ground state n equals to 1 and k equals to 2 equals to sin pi x by 2. And the probability, I have just write this formula a into 0 to 2 x into x minus 2 into sin pi x by 2 and dx and whole square. And they asked me to stop here and just move to the next topic. So at last they asked some question on STR, that is special theory of relativity. They just asked me what are the basic postulate of STR. So there are two postulates: the laws of invariant, which means all laws of physics remains invariant in all inertial frame of reference, and second is consistency of speed of light, that is speed of light is constant for all the observer at various systems. So that's it. Thanks to Sutta sir and Physics Galaxy for giving me this opportunity to share my interview experience. This might help you for your upcoming interviews. So thank you.